All right. Sorry this is late, guys, but you know. This is chapter 6. We're doing 6.2 and 6.3. And in this, we're talking about the trinomial. Now, we have for 6.2 trinomials that look like this, right? And then for 6.3, we have trinomials that have a number in front besides 1. So it's really this guy that makes it different for 6.3. Now for 6.2, we use this method, X method if you want. We put the middle number up here, we put the last number down here, and then we say what two numbers multiply to give me C and add to give me B. For this one, we set up a snowflake. This is called a snowflake method. We set up B in the top again, the middle number, but down here we're going to have A times C as a single number. We're going to multiply those two together, and then we say what two numbers multiply to give you whatever that is, and also add to give me B. And then we'll put A above both of them, and then we'll reduce these side fractions. So I don't know if any of that makes sense by looking at the rules, at the notes. But let's look at some examples, and maybe it'll solidify for you. So here we have x squared plus 12x plus 32 for number 1. Now this belongs in the first category. So we're going to use the x method. I'm going to go off to the side. Just an x, no snowflake. And then we'll put 12 up here. I'm going to put 32 down here. Now, I have to think of two numbers and multiply to give me 32. And that means I could have 1 and 32. I could have 2 and 16. I could have 4 and 8. And then as soon as I see the pair of numbers that add up to give me 12, like that didn't work, but this one does, those are the numbers. Now once I have these side numbers, they are going to become x plus that number, and then x plus that other number. So 4 becomes x plus 4, 8 becomes x plus 8. And that's it. You're done with that. So it's all about finding these two numbers once you set up your x, okay? That's your example. Now let's just get into it. And then we'll come back whenever we look at the other type of trinomial with number in front. So x squared minus x minus 30, we're going to set up the little x, plus times. And you don't need this plus times here, I just like it there just because it reminds me. -1, if you don't see a number, that's the number. And then -30 goes down here. Now it's important for you to note that the negatives go in there, but the x's don't. There's no letters, just numbers, and they're negatives if you have them. So over here they're positive, so everything was positive. So here we're going to look at this number. We're going to say numbers that multiply to give me 30. Now, but instead, in the past when I was adding to make 12, now because it's a negative, I'm going to be subtracting. So I've got 1 and 30, that makes 29. Nope. I got 2 and 15, that makes 13. Nope. I got 3 and 10, that makes 7. Nope. I got 5 and 6. Ooh, that makes it. So I need 6 and 5, but the larger number has to match the sign of this, because when I subtract, I always keep the larger number sign. So that means 6 is going to be negative and 5 is going to be positive. Now, just to make sure, it's -6 times 5 is -30. -6 plus 5 is going to subtract to give me -1. Good to go. So the answer becomes x minus 6 and x plus 5. All right. Cooking with gas. I don't know why that's something I say. I think it's because it's a culture thing, you know? Like whenever, you know, I want to go somewhere and I'm trying to get my family ready to go, I say something lame to get them to go. I'm like, we're burning daylight. All right, middle number goes up top, last number goes in the bottom, and I say, what two numbers multiply to give me 88 and subtract to give me 3? So if I go through all the numbers, it's going to be like, 1 and 88, that's 87, nope. 2 and 44, that's 42, nope. 3 doesn't go into it, I don't believe. No. What about 4? 4 and 22, that gives me 18. Nope. Let's see, 5, no. 6, no. 7, no. 8 and 11, ooh, there they are. So 8 and 11, but the larger number has to match, so that means the smaller number is negative. Right? So answer, x minus 8, x plus 11. So sometimes you just got to find those two numbers. And what I'm doing is I'm listing them off as I think of them, and I'm going in order, 1, 2, 3, 4, 5. But you could just, whatever two numbers pop in your head for 30, like if 5 and 6 popped up there and they work, you don't have to list all these. You just write 5 and 6 and go with it. Same thing with 88. 88's 11 times 8. Ooh, that worked. You know? No need to write them all. I was just giving you some choices. Or when I'm done eating Doritos, here's another lame one. Get these things away from me. Because I've eaten like 50. All right, so it also works when it's x squared, xy, y squared, rather than just x squared, x and number. This works as well. You can still use the x method, just the numbers, plus times. 6 goes in the top, 8 goes in the bottom. And I say, what two numbers multiply to give me 8 and add to give me 6? So it's 1 and 8 is 9. Nope. 2 and 4 is 6. Yep, those are the ones. Okay, so when I write my answer, it would be x plus 2 and x plus 4. But because my original problem had x's and y's, it's going to be x plus 2y, x plus 4y. That's it. That's the only difference. Is that it's x and then y and then x and then y. And if you're ever wondering if you're doing it right, if your answer is right without looking at the answers, you can just FOIL this out and see if you get what you started with. And that's a little tip for you when you're taking the quiz, in case you forget how to factor something. Like if you forget the X method or Snowflake method, then all you have, did I say that right? Yeah. Then all you have to do is just sort of take the answer choices and FOIL them out and see if you get what you started with. Now this one has a number in front, but, I don't know if you can see that, but they all have a common factor, don't they? So GCF is always in effect. So GCF always first. And if they have a common factor, we're going to write it, and then we're going to divide each one of them by 3. We did that last week. I think. Yeah, 6, 1. So when they cancel, you're left with x squared. When they cancel, you're left with x. And then when they divide, you get 6. But you can keep going. So this is a trinomial, but there's no number in front. That 3 is no longer involved. So we can use the x method again. So no need for Snowflake when there's a GCF. -1 and then -6. And then we're going to find two numbers that multiply to give me 6, but subtract to give me 1. So 1 and 6 give me 5. Nope. 2 and 3. Yep. Those are the ones. The larger number has to match, so the 3 gets to be negative. And there you go. So this becomes x plus 2 and x minus 3. But don't forget that little 3 in front. That little GCF has to be in your answer. All right. And then we'll do number 6 right here. Same deal, x cubed minus x squared minus 56x. It has a common factor as well, x. So when I factor out an x, I'm left with x squared minus x minus 56. All right, divide by x. All right, so this one can use the x method as well. -1 goes up here. -56 goes down here. And then I go, what two numbers multiply to give me 56 and subtract to give me 1? 1 and 56, no. 2 and 28, no. 3 doesn't work. 4, yeah, it does. 4 and 14, no. Let's see, 5, no. 6, no. 7, no. Yeah, no, wait, 7 and 8. There we go. That's the one. Ooh, let me just circle those because I wanted to. Okay, so 7 and 8. Larger number keeps the sign, so it should be negative 8. So this becomes x plus 7 and x minus 8. And then bring down your x, and you're all done with number 6. Okay? All right, so x method. If there's a number in front, always check for GCF first. All right, number 7. So with 7, there's a number in front, but there is no GCF. Now it's 3x squared minus 11x plus 10. They don't have anything in common. Sorry, it's a squeaky floor I'm sitting on. So now I have to use the snowflake. So I draw a little x, and then I draw a line through it like that. Put a little plus times. Middle number goes in the top, just like before. But now it's 3 times 10 in the bottom. In this case, 30. It only works if you say 3 times 10, this. And now we get, what two numbers multiply to give me 30, but add to give me negative 11? So just 1 and 30 give me 31. 2 and 15 give me 17. 3 and 10 give me 13. Ooh, so close. 4, no. 5 and 6, there we are. Those are the ones. But look, they both have to be negative now because they have to add, first of all, but they also have to multiply to give you a positive 30. Okay, so that's the first time we'd seen that in this practice sheet. Okay, so this works like the x method, only now we have to put in that first number above both of our answers. And then if it doesn't reduce, I'm going to circle it. And if it does reduce, draw a little arrow and then divide a 3 out of both. Like so, and then circle that. Now notice, with these side fractions, the bottom number can be negative. It's okay. And if this was ever a number over 1, you do not make it into a whole number. Keep it like that. You need 2 numbers. So the idea here is that it's blank x plus blank x plus blank. So there's 4 blanks now, 2 for each parentheses, and those 2 come from these fractions. So 3x and then minus 5, and then 1x and then minus 2. So top to bottom, left to right. Top to bottom, left to right. Done. Right? So the snowflake is a little more complicated, and like there's fractions that we have to reduce, but I feel like you guys are good at reducing fractions. I think that of all of the things about fractions, I think that's what you're good at. So I wouldn't worry too much. It's not too bad, right? 6x squared plus 17x plus 12. We're going to do the snowflake because they don't have anything in common. So 17 goes up here. 6 times 12 is 72. That goes down there. All right, so we're going to say what times what gives me 72, but also adds up to give me 17. And 72 is 8 times 9, and they add up to 17. So like that was one of those things that I remembered about 72, is that it was 8 times 9 for my times tables. But if you didn't, take your calculator and then go 72 divided by 2, enter. 72 divided by 3, enter. 72 divided by 4, enter. 72 divided by 5. Keep going until you find your 2 numbers that work to add up to 17. Okay? Okay. Now, I got to put that first number on top of both of them. And look, they both reduce. 6 over 8, you divide a 2, you get 3 over 4. I'm going to circle that guy. 6 over 9, you divide a 3, and you're left with 2 over 3. I'm going to circle that guy. Okay. And if you need to write divide by 3 like this, perfectly fine. Divide by 2, divide by 2. All right, so the way this works, 3x and then plus 4, because it's positive down there now. And then 2x plus 3. All done. Very nice, huh? That should have come down here. Okay. Number 9, we get 6z squared plus 5z minus 6. Snowflake again. See a pattern? Okay, 5 goes up here. 6 times negative 6 is negative 36. Plus times. So then I go, what two numbers multiply to give me 36, subtract to give me 5? And I'm like, I don't know. 1 and 36? No, that's 35. 2 and 18, that's 16. Nope. 3 and 12, that's 9. Nope. 4 and 9, that's, oh, there it is. Right? And so I'm going to write 4 and 9. Now, one of them has to be negative. The top number and the bigger number have to match. So this guy, 4, gets to be negative. All right? First number goes above both of them. It's a 6 again. Hey, this reduces again, both sides. So we divide by 2, we get 3 over negative 2. Divide by 3, and we get 2 over 3. Oh, I just did that. Oh, goodness. All right, so we get 3z minus 2 from the first one, top to bottom, left to right. And then 2z plus 3, top to bottom, left to right. All done. Easy peasy lemon squeezy, right? Oh, God, that was lame too. What's wrong with me? 8x squared minus 28x. I hope there's not a timestamp on this video. Because if there is, you're going to see that I'm up at 2:23 doing this. Because my sleep schedule is just messed up. Okay, so look. All of these have a common factor. Right? They're all even. But not only that, 4 goes into all of them. What I do is I always start with the smallest number, 8 in this case. And I go, does 8 go into 28? No. No, it doesn't. Then I go, what's the next highest factor? 4? Yes. Yes, 4 is my guy. They don't all have an x, but they all have a 4. And then I'm going to divide a 4 out of each one of them. And I'm still going to have a number in front. But hey, made our total numbers a little smaller. That's nice. Because otherwise, I was going to say negative 28 in the top and then 8 times 16 in the bottom. And that's a bigger number. And I don't want to do that. Plus, if I did that, I would screw up. I would get the wrong answer. You would get the wrong answer if you did the snowflake before the GCF, by the way. I don't know if you know this. So, do not do snowflake before GCF. If you needed to see that in writing, there you go. Do not do the snowflake before GCF. Always look for the GCF first. So when you do the snowflake now, forget about the 4. He's not in there. And it's just going to be negative 7 up here, and it's going to be 2 times negative 4 down here. So now I go, what two numbers multiply to give me 8? Subtract to give me 7. Well, that's 1 and 8. But the larger number has to match the top. So there you go. Now we're going to put this number first above, not the 4. Remember, once we got the 4 out of there, he's no longer involved in the snowflake. He's no more 4. That guy is not there. Now, there's this guy. He's, but different 4. Anyway, 2 over 1 does not reduce to a whole number. Leave it like that. This one, you're going to divide by 2, and it's going to reduce to 1 over negative 4. Right? So he will be 2x plus 1, right? Top to bottom, left to right. And then 1x minus 4. Now, I don't have to write the 1, but you can if you want. Don't forget your 4 from the front. There you go. That's how you do that problem. I think we have 2 more. This is funny because this is the last piece of paper I have in this house. I'm going to have to go get some. I wonder if that's an essential supply. They probably have some at Kroger, right? People are getting toilet paper, not regular printer paper. Oh, look, they have a GCF. Here's a pattern here. They all have a 9 in common. So the first, I go, what about 18? 18 going to 81 evenly? And no, it doesn't. So then I go, what about 9? 9, yes. 9, yes. Ooh, it's a 9. So I'm going to divide by 9. Divide by 9, I get 2y squared plus 9y, 81 divided by 9, minus 45 divided by 9 is 5. So now I'm going to do the snowflake with those three numbers. Forget that 9 on the outside. He don't matter. The middle 9 goes in there. 2 times negative 5 is negative 10. So then I go, what two numbers multiply to give me 10 and subtract to give me 9? And that is 10 and 1, right? But the larger number has to match the top, so this is going to be a negative 1. Now this number, 2, goes above both of them. And this reduces to 1 over 5. And this doesn't reduce. So 1y plus 5, right? Top, bottom, left, right. And then 2y minus 1, top to bottom, left to right. Don't forget your 9. All done. Right? Last one. We have x to the 5th plus 2x to the 4th minus 3x to the 3rd. Okay, and like the number 6 problem, we have this x that they all have in common. So we got to factor out the GCF that is an x, and it's the one with the smallest power, x cubed. And if we divide by x cubed out of all of these, then we'll be left with x squared plus 2x minus 3, because they'll both cancel there. Well, hey, this isn't a snowflake problem. This is a regular old x problem. Sorry, that x was pretty sad. But 2 goes in the top and negative 3 goes in the bottom. We go, what two numbers multiply to give me 3 and subtract to give me 2? That's 3 and 1. Larger number keeps the same sign as the top, so 1 has to be negative. So it's x plus 3, and it's x minus 1, and it's x cubed from the GCF. And that is, what is it, 6.2 and 6.3.